Hi, I'm Kumuda. So I work with ADC Drivetrain as a senior data architect. And also I'm the co-founder of Unimonk and GoIQ. So I'll be talking about AI on lockdown, like deploying ML pipelines in controlled government spaces. So how many of you think that AI pipelines is like an offline dating app with so much restrictions, and it's very hard to deploy in government sectors a lot? So anyone? Is it really difficult to have AI and compliance and security, especially in the government fields? Yeah. So when you think of AI pipelines, you usually probably imagine like shiny GPUs in the cloud, like hugging the data like Netflix hugs your data. So just imagine AI inside a bunker. No internet, no GitHub, no data pool, just USB sticks which you carry around. That's my world, like AI on lockdown. Today, I'll show you how Kubernetes, like orchestration and discipline, allow us to deploy like even complicated ML pipelines, even the most restricted environments. So this is my agenda, like how much like government faces the challenges, and like what are the solutions we can think of like when we are deploying AI systems, and what are the compilers. And I'll be going through 2 case studies, one in DC and one of the Department of Education. So that's where I'm going to head it. Don't worry, I'll go through it quick, more than the data scientist grabbing free GPU credits. So why does it really matter? AI in government is like not the hype. It's like more of mission critical. In defense, we have like aircrafts. We are predicting aircrafts and tanks. But will it fail or not? When we go to borders, we have drones scanning the real-time activities. But when we come to healthcare, we are helping out federal and veterinarian hospitals, like, that's what happens. But when it comes to startups, AI in government can't work on cloud. So why? It's the SSE, government's sovereignty and compliance. So the question is, how do we innovate like AI, which lives inside the walls? So there's always a friend who says, hey, can't share the location. It's classified, especially a government officer who is in a private kind of location. That's what really happens. So what are usually the challenges we face in the secure spaces? Air gap, like there's no internet, like usually we have like even a small pip install. It's not allowed in a government space. So you have to like burn into DVDs or USB sticks to even install. So we have like data residency laws, basically, which says like you have to stay, it has to stay in one base or maybe one country. Sometimes even in one room. So it's really difficult. We have zero trust. Like each packet has to authenticate. Like you don't even each pod doesn't even like kind of like trust each other. We need to have like a clear base rules access. Like forget RBAC. This is human-based access control. And for each approval bottleneck, even moving a single CSV from one point to another, it may take even like weeks, more than like getting your passport renewed in DMV. So yes, that's one of the challenges. Like so, when it comes to AI paradox, so that's what we call like 3 things. That is like performance, compliance, and velocity. So performance, like models should be mission accurate. You can't say like, hey, I'm gonna like we're gonna detect missile threats like 95%. That's not good enough. So we should be very particular about the performance. Compliance, there's a lot of like alphabet soup of regulations. We have HIPAA, DOT, FedRAMP, so many things like we have to follow. But still, with this so much compliance and performance, leaders always want like Silicon Valley speed of the AI. So you'll be juggling 3 balls, like accuracy, compliance, and speed. But if you drop one ball of it, a person maybe in a suit say, hey, they can give you a 30 pages of compliance checklist just to compile all of these things. So the design principles of like to have a secure pipelines is one of the important things when you think about deployment. So one of the things is like isolations, like pipelines must run like a sealed submarines. So you can't like just have it like on the cloud or anything. Reproducibility, deterministic like builds. Like you have to plan everything, so you shouldn't have no surprises like, hey, I have this new update or something like that, especially when it comes to government. provinces, each data set, and each artifact traceable. You have to do all the designs, like make it traceable, like a CSI evidence, basically. That's how we design. So offline interface, model must run at the edge with zero internet. There's no internet accessibility or cloud or anything. So logs that are immutable and permanent and tamper-proof, that's how you do it. So this is just like not like a design principle, but they are the survival rules, which you have to follow for the design principles. And why Kubernetes is still the backbone, but it's still in a small confinement. You can't have like open, like you have to have like open from clusters, which you have to work through like as a mini clouds. Only signed or verified containers like you can are allowed inside the whole system. Zero trust, even like even each pods can't even like gossip with each other without permissions, and everything is offline, even CI/CD. Kubernetes still works, so it's still wearing an ankle monitor. It still works in an offline version. So orchestration tools, that's one of the ways you can do a ML pipeline. So how like Kubeflow pipelines, you reproduce the ML lifecycle management. Argo flows, that's DAGs with like, you should have like a human approval steps. Without that, this workflows will not have any approval, like you can't even like deploy it. Airflow, that's the schedulers for your compilers, like hardened schedulers. That's one of the ways. Pattern, like automation plus accountability, but still call it like human CI/CD. Like you have to have like a Bob with 5 clearance process. That's all. So for the whole life cycle, so first thing is data ingestion, which stays local. Offline, that's for where we do. Training, we have it on the restricted GPUs. Validation, you check the accuracy and compliance. Signing, you need digital signatures and human approval. That's more important. Without human approval or digital signatures, you can't overstep anything. Deployment, nothing is online. You do it offline, but in a containerized interface. But every runner must show like 3 forms of IDs, especially to a human who gives you approval. It may take weeks or something, but it depends on your offline approval from a human. So here's a case study like of one of the Department of Defense. So they wanted to do a predictive maintenance for a military vehicle, so which took like almost like the update took almost 6 to 9 months. But the models were outdated when they wanted to release, and like the whole deployment was like stale, basically. So cloud was forbidden. So what they did, they came up with the solution. So they built on-prem Kubernetes clusters and Kubeflow for pipelines and Argo workflows, but with human checkpoints. So that was the one way, and the one main thing they did was like policy as code using OPA and Cairo. So what was the outcome? Release cycles dropped from 6 months to 6 weeks. That was like a total drop. But predictive accuracy went up to 22%, but they did maintain the compliance. That was like most important thing. Out of all of this, one thing we learned is like fear tanks broke down during missions, but this is a high possible availability, like military edition from 6 months to 6 weeks. That was one of the most case studies that happened. But when we moved closer to our DC home, we have like one case called the Child and Family Service Agency. They were just not building air-gap pipelines, but they did face a trust problem. So how they came up with like how to adopt AI responsibility in each citizen services. So in May 2025, they came up with a policy called NIST AI Risk Management Framework. So they did one thing. They committed to define purpose and alternatives, safety and equity, and enforce human accountability. And one thing they wanted to do is like protect privacy and cybersecurity. So one thing they showed was like side of government, AI in government, but not just technology, but governance and fairness and trust. That's what their policy was. But out of all this, one main thing which always comes to the checklist is compliance. Compliance is not like built at the last, it's a built-in. So policy as coder, we have to deploy rules at any runtime. So model card and fact sheets are, provide transparency. So logs always guarantee traceability. So that's one of the things we always look out for, especially if you're into blockchain, you always go for tamper-proof audits. Compliance, like, it should not be a blocker, but it should be an oxygen for you to live through the traceability. So, but one question it always comes with is like, how do you do the offline interface? Like with all the ready models for disconnected like operations, you're going offline, but they do have like, especially border drones, submarines, you always see that. They usually have pre-packed ML microservices. They do have like quarterly model drops. They even updates a lot of model offline, and always they have one thing is that edge-ready deployments. For example, if you see V5 drones, they run totally fully offline. They don't go and look for Starbucks Wi-Fi whenever they need it. So there's no need to share password for that. So one thing is like I always say for ML deployment in AI government is like it has to act like a submarine, silent, isolated. They carry their own oxygen, but they do service only for controlled updates. ML model always need updates, just come out and like have it, but always resilient and still water. So yep, that's one of the things which always thinks. But when we see the future, what would be the next feature of like ML pipelines, especially federated learning? I think most of the banks already use federated learning, so we could go in that way where each agencies can share their data and train the models, but not totally collaborate with each other and sharing raw data with each other. And also synthetic data, it always enables training without any privacy risk. So that's one of the ways. And even quantum safe cryptography is one of the that's one of the threats you always see. But government AI is moving towards sovereignty and privacy preserving. So quantum ready is like one of the cryptography is one of the best options. So I just want to say that AI in government does not have to move slow. It has to just move fast. And we can deploy ML pipelines even offline anytime. That's all. If anyone has a question, like.